Okay, so good morning. So today this is the second day and this is the first lecture of second day. So in this we will start with the very basic things about the climate change, and the very second lecture will be taken by Professor Lixin Wang, and in this lecture I will discuss about very basic about climate change, and in the further next lecture we will start with the IPCC. So if we talk about anywhere, either it is a TV or a documentary or a broadcast, or we can say the short-term courses or any conferences, everywhere we are looking at climate change. So the very basic thing is that whether this climate change and global warming are the same or not. This is very basic question. So what do you think about it? These are the same thing, or these are two different things? Whether the global warming and climate change are same or not? What do you think? It is same? No, these are not same. These are two different things. We can say one of the reason to cause the climate change is global warming, but these are not the same. So what is the basic difference between them? So if we talk about the global warming, the gradual increase in the Earth's surface temperature is known as global warming, and whenever we talk about the climate change, we are considering the long-term change in the global weather patterns. So what do you mean by global weather patterns or long-term change? How many minimum number of years we need to consider for long-term? 30 years or more than that? Minimum 30 years we need to do. Even for the downscaling itself, whenever we are doing the statistical downscaling, the minimum number of years to do the downscaling, the minimum means below than that we cannot go is 20 years, and the desirable is 50 years. So if we are talking about the long-term weather pattern or change in the long-term weather pattern, then it is known as a climate change. Otherwise, the simple gradual increase in the Earth's surface temperature is global warming. And even 97% of scientists agrees that climate change is happening across globally. So why this topic is so important for us? Across the global level or across India or any regional level, why we are very afraid about the climate change? What is the importance of this? So if we talk about on a global level, climate change, Henry Paulson, who is a former United States Secretary of the Treasury, he told that climate change is the single biggest risk that exists to the economy today. Second important thing, as per the UN United Emission Gap report in 2019, they told that we are on the brink of missing the opportunity to limit the global warming to 1.5 degree. I think you know what is the limit for global warming we have decided initially. Initially it is decided that we have to limit the temperature increase to 1.5 degree preferably. However, we should not go beyond the 2 degree centigrade, but preferably it should be 1.5 degree. But looking at the current scenario, it is looking like impossible condition for us that we will not limit up to 1.5 degree or 2 degree. If we talk about the Mark Carney, he is a governor of Bank of England. So he also stated a definition or a statement related to climate change, that companies that don't adapt to climate change will go bankrupt without any question. So these are some of the terms related to climate change and why it is important based on the economic purpose or on a global level. But as a researcher, what is the importance of climate change to us? Why we are concerned about the climate change? So there are different risks which are associated with the climate change. If we talk about heat waves, flood, drought, heat waves, cold waves, droughts, flash drought, flash flood, like these are the direct risks which are associated with the climate change. If we talk about the indirect effects, along with the direct effects also there will be some inherent direct effects also associated with this. For example, if drought condition is there, so that will be a problem for us. People will start migrating from that place. Even for the flood condition itself, if it will persist for a longer time, so people start migrating to the another place. Similarly for the heat waves, similarly for the cold waves, due to drought conditions, agriculture production will affect. Due to that also people will start migrating, and due to flood condition, infrastructural damage will be there. So if we talk about direct risk, we have observed a huge change in the temperature rise. Means urban temperature is rising 2.5 to 4 degrees centigrade than the pre-industrial level. I think yesterday itself Dr. Somil has shown that how the temperature condition is changing across before pre-industrialization and after the pre-industrialization period. So you can see that this increase in the temperature in the last 50-60 years is causing a huge impact on the different extreme events. I think you also heard about the urban heat island effect. So it is also one of the effect of the climate change. If we talk about the flood risk, so at various places we are looking at flash flood conditions. Like at Uttarakhand, we have seen the same effect of flash flood. There is a drought risk associated with climate change, due to which we have arable land productivity is going to be reduced in future time. We found that there is a lower crop yield or crop yield reduction in terms of wheat, rice, maize. Why I am saying wheat, rice, maize? Because these are the major crops which we are expecting across the India. So these are some of the 5 critical global environmental changes due to climate, that is warming, increasing temperature, changes in the global water cycle. Due to temperature increase, we are saying that there is a declining in the glaciers or snowpacks, and if these glaciers will start melt, what it will result in? It will result in sea level rise and finally the ocean acidifications. So we are saying that this is a climate change, this is the effect of climate change, this is a direct or indirect effect. But what proof do we have that whether the climate change is happening across globally or across India? So if we talk about the major impacts of climate change across India, these are some of the data set from the WMO from 1970 to 2019 itself. So from here itself you can see that initially, if we talk about the very first figure, the first on the x-axis we are showing the data set for the 10 years. So initially from 1970 to 1980 or 1979, we have number of disaster reported is 711. These are consist of drought, extreme temperature, floods, landslides, storms, wildfires. Out of that, in 1970 we have only 711 events occurring across globally. However, you can see just after 10 years it is becoming the double of the figure, that is 1410 events. In the next 10 years it is increasing to 2250, then it is increasing to 3536, and finally in the next it is 3165 events. So you can see from last 50 years we are increasing from 700 to more than 3500. So this is the impact of climate change, and it is clearly indicating that climate change is happening, and due to which we have number of disasters across globally. Similarly, if we talk about the number of reported deaths, initially you can see this is showing the opposite figures as per the number of reported disaster. Why it is so? If number of disasters are increasing, number of reported deaths should also increase with it. Why it is showing a reduced number? Means initially in 1970 it is 556k, and in last decade it is 185k. Is there any reason behind it? Because due to climate change, disasters are happening, but the government or on a global level we are becoming the resilient to the disasters also. Not in terms of disasters resilient, but also we are giving some facilities so that we can protect our people from the disasters. So that is the reason that deaths are less, but we cannot stop the disasters to happen, but we can take the mitigation or adaptation strategies so that we can save the life. The third important thing which we can see the impact of climate change is economic losses. You can see that initially these figures are in American US dollar in billion terms, and you can see that initially it is 175.4 USD billion, but the same figure is increasing to 289 in the next decade, then 852, then 942, and right now it is 1381. So this is the economic loss we are facing due to climate change across global level. So you can see that we are increasing in the number of reported disaster on every single decade. We are losing lot of economic losses in USD from 1970 to 2019 itself. So this in all we can say that more than 11,000 disasters are reported, out of which 2 million deaths happen and 3.64 US trillion in losses globally in last 50 years. So this is the clear perception that it is showing that we have a proof of the climate change across global level. If we talk about the climate change across India itself, we know that more than 54% of India is facing high to extremely high stress conditions. So mostly these are some of the clips, and I am showing this because we are very vulnerable to temperature condition, we are very vulnerable to flood conditions, we are also vulnerable to the flood heat wave conditions. The most important part of extreme events across India is that, for example, you can see this figure that despite the floods, some parts of Maharashtra are reeling under the drought-like conditions also. It means the same area which is facing the drought in the next coming month, that is the same area is also experiencing the flood conditions, and that is the simultaneous behavior. Means, for example, if you talk about the river basin wise, I think Mahi river basin is that river basin which is experiencing these types of situation, that one of the event is completing, the next opposite one is occurring there itself. For example, you can find the drought simultaneously with the flood conditions at the Mahi river basin. Similarly, there are different areas across India which are facing the same situation, that initially they are facing the drought condition, in the next coming month they are facing the flood condition. So such type of extreme events is very hard to predict, because if you are managing the drought condition, in the next coming month you have to face the flood conditions. So continuously, if drought is there, you can manage the things, you can predict the things, you can do something for that. But if the same event is happening and after that the different one is happening, so it will be very difficult to us to mitigate that thing. Other than that, if we talk about the flood, other than that, if we talk about the glaciers also, because if we talking about climate change, we cannot ignore the glaciers conditions also. So one study happens and it clearly tells that if we are not protecting the climate from the climate change, the Himalayan glaciers will risk losing 75% of their volume by 2100 due to global warming. It means your grandson will not able to see the glaciers. Whatever you are able to see, your grandson will not able to see the glacier. What is that? So you have to show them in the video itself. These are some type of the glaciers we have in 21st century. After that, might be more than 75% of the glaciers will be lost. So if we talk about the India itself, we have different facts about the climate change. If we talk about the flood condition, more than 40 million people were affected by widespread flooding in the Indian subcontinent during different 5 or 6 years as per UN report. If we talk about the drought also, India is one of the most drought prone countries across the world, because we are facing lot of drought events across every single years. If we talk about heat waves also, right now you can feel it, because yesterday we have a very high temperature conditions, and every year from mid-March to May or mid-May to June we have severe heat wave conditions. In the next tomorrow itself I'll take the lecture on heat wave, and we have conducted a heat wave study also. So we will define how we can define the heat wave and severe heat wave, what is the basic difference between them, and how we can define the heat waves, means what are the different conditions to define the heat waves. If we talk about the extreme precipitation, because right now we are if we take a look at the literature, we can see that lot of studies are carrying out for the extreme precipitation. So in the last 65 years, from 1950 to 2015, a study has been carried out by Roxy et al. In 2017, and in their observation they clearly mentioned that in last 65 years the events of extreme precipitation has increased three times. So this is the vulnerability of India in terms of flood, drought, heat wave and climate change. So these are some of the proofs which indicates that okay, climate change is happening across India also. Okay, so what do you think, what is the main reason why this climate change is happening across urban area? Because if you think about that, which one is the more contributing factor to climate change, either rural area or urban area? So urban area is the major contributing to the climate change. For example, if we talk about the expected figures of the climate urbanization in 2050, so after 2050 we will reach that 55% will increase in urban water demand will be expected by 2050. More than 2/3 of the global energy is consumed by the cities only, so that's why they are contributing more to the climate change. If we talk about the greenhouse gas emission, more than 70% of emissions comes from the city itself, not from the rural areas or not from the villages. If we talk about the unmanaged waste, 93% of waste is unmanaged in low income countries. If we talk about the constructions also, more than 0.6 to 1.3 million square kilometer of new built up urban areas are expected to be added in the next 30 years. And if we talk about the urban population, more than 2.5 billion people or more people will be join the cities by the 2050. And if people will join, all the facts which I am discussing will be increased very fastly. For example, if more than 5.5 billion people will add into the city level, urban water demand will also increase, the consumption of energy will also increase, greenhouse gas emission will also increase, and we need to build more construction or more areas. Okay, so this is the 1.5 degree thing which I am discussing earlier, that as per the climate scientists, they have think that 1.5 degree is the level which is associated with the less devastating effect than higher level of global warming. Means they have decided that up to 1.5 degree we can stop the temperature, because up to that the effect of global warming is not very high, it is less devastating. However, after 1.5 degree, this will increase severely and expensive effects of climate change in this. So today we still have the chance to limit the global temperature to 1.5 degree, but by looking at our system or our tradition, whatever we are doing for the climate change, we are one of the contributor to the climate change. So it is very difficult to stop at 1.5 degree, but we can stop it up to 2 degree if we want. So these are some of the climate change issues. Then if there is an issue, we have to solve that issue. There is problem, there should be a solution also. So if this is the problem related to climate change, then what is the solution at a national level or a global level or at a regional level? We have to think about it. So for the climate change, I think there are several association or organization at a global level, And if we talk about it India level, there is a national action plan on a climate change. I think you have heard about this. This is a national action plan on a climate change, which is started in 2008. And the main objective of this is to divide this action plan to the state teams, that is state action plan on climate change. And in each state action plan, they have divided 2 units to take or to collect the data sets related to climate change across the state. The first one is the state action plan on climate change have unit, that is state climate change cell, and second one is the state knowledge center on the climate change. If we talk about this in Madhya Pradesh, this cell is available in the Bhopal only for the Madhya Pradesh state. So these are some of the action plan on climate change, but the problem is that if these are not getting the proper data set, so what is the government purpose, or what is the government behavior, that what they are doing for the climate change? So if we talk about the smart city missions, so smart city mission, what is the main objective of smart city missions? To make the city smart only? Sustainable. Because since we are growing, we are updating ourselves. From bike we are going to the car, from fan or cooler we are going to the AC. So we are updating ourselves. Similarly, along with this, we are causing the climate change. So if we are developing the cities, we must develop the city in the sustainable way. So in this, we have sustainable environment, for example, renewable source of energies, or if we talk about the urbanized transportation, we must use electric vehicles and all. But in these smart city mission, if you find out the report of 2015 from the MOHU Government of India website, you will see that there are no such plans or policies that is existing for the estimation and mitigation of risk due to extreme events. So we need a plan that can also exist in the smart city, which can estimate the risk and mitigate the risk. Means what is the risk which is associated with the different disasters across different cities, and what is the mitigation plan for that particular disaster in that particular city. So such type of plan is right now, it is not existing in our smart city plan, but we must have such type of plans. Some of the government initiative is also related with this. This is a study which is carried out by National Institute of Disaster Management, that is Climate Risk Management, CRM. But since this study has been carried out in some states, and carrying out such study at a state level is very difficult, because a state is a very big study area, so it is very difficult to collect the data very precisely and do the things in proper manner. So we need to conduct this study on a very finer resolution, like city level or like urban level, we can do that. So this is all about what is climate change, how it is happening across globally, how it is happening across India or smaller region, what the government is planning to tackle the climate change. But what is the problem, why we are not able to properly estimating the climate risk? What is the issue with this? Why we are not able to predict the climate change? Why we are not able to do the proper mitigation and adaptation to the climate change? What is the issue related to climate change at present time? So if we talk about this, right now we do not have do not have scientific information database. It is insufficient observation or scientific information database right now we have. Second, if we talk about this, we have inadequate knowledge on the disaster risk in different sectors of economy. We are just looking at some sectors of economy, because this climate change is affecting all the sectors. Either it is agriculture, natural ecosystem, health, biodiversity, coastal zones, etc. So we must have adequate knowledge regarding the effect of climate change on different sectors. And the very important thing is that, for example, I think you all are related to climate, you are working on climate change only. Some of them you are working on impact of climate change on crop or agriculture, or you are showing the drought conditions. How many of you have visited any agriculture or farmland during your study? means you have visited your study area. For example, if you are working on Bhopal, so have you visited any agricultural land during that? If you are working, if you are finding out the impact of climate change on the crop production like wheat or any area like Madhya Pradesh or Bhopal or any district, have you visited? Have you visited? Any other? Who is working on drought? Anyone who is working on drought? Have you visited anywhere? I think you are working on flash drought. So have you visited Rajasthan? I think you visited city. So if you are visiting Bhopal to DB City Mall or any other, then it is not related to your agricultural drought. You have to visit the agricultural land. Have you ever talked with farmers? For example, you have found out the drought conditions. Okay, this is the agricultural drought. So that is anyhow it is related to the farmer. End user is the farmer. Have you talked about him ki I am trying to find out the agricultural drought across your area. So this is the condition, and I am predicting the future drought condition, and this will be the condition. So have you asked anything or have you suggested them? So this is a problem across everyone, even with me and you, that we are doing the research for the end user, that is farmer, but we are not okay that we are going to him, we are talking to him, and we are giving some inputs that this is the issue. For example, if I have worked on the impact of climate change on some crop like maize across Bhopal, that paper will get published, I will get something from that, maybe I get promoted due to that paper, but the main purpose of that paper is not served, because a farmer will not ask the Google Scholar link or the paper or DOI of that paper or a PDF of that copy that okay, send me this paper, I'll read and let me know what is the impact of climate change on the wheat. So this is the problem. That's why we are not able to tackle the climate change, because there is a poor connectivity between researcher and the end users, and this is causing the problem to tackle the climate change. Right now we don't have any framework that can incorporate the time evolving climatic parameters. So right now if we talk about this, we need a risk information conveying platform. What is risk information conveying platform? For example, if a district collector or collector is there, so he will able to understand what is drought, what is flood, how it can be determined, like what is SPI, what is SPEI, what is POT. He will not understand each and every single thing until unless he is a climate researcher. So if you are finding out the drought conditions or heat waves, so you should make some platform which is very user friendly, so that any collector or any administration person have that platform or that app in his mobile, and he can see the situation what will be going to happen in next coming 2-3 days regarding any climatic extreme events. So that type of risk information conveying platform is still missing across different parts. So it is very important that we can develop a E2 that can provide the risk across different particular area, so that any administration or policy maker can just see the things that what is going to be happen in next coming months or next coming days, so they can plan accordingly. But since as a researchers we know, but we are not conveying the information to them, so as a researcher we can't do anything on a policy making system. So we need a tool which should be related to this. So what type of tool we can develop? A tool which discuss about the climate risk estimation and assessment tool. Means a tool which can find what is the extreme climatic risk estimation and assessment tool. Why it is required? Because it can fulfill the requirement of climate extreme risk assessment platform. And for whom it will be useful? It will be useful for institutions, government bodies, researchers, students like us, and the private firms which are dealing with the climate change. So such type of tool we can develop, in which we can discuss or we can show the integrated online risk visualization platform. It means, what is visualization platform? It means in online way, in the real time, we can see what is the risk of any particular climatic risk or any particular hazard or the combination of hazards. The second thing is single and multi-hazard risk assessment. The problem is right now we are dealing with the individual hazard, but it is not possible that always a single individual hazard will come. It may come individually, it may come with other hazards also. So we must have single risk assessment or multi-hazard risk assessment. The third thing is identification of drivers for the extreme events. Means we must know what are the major drivers which are causing these disasters or hazards. And finally, we must show what is the vulnerability and what is the exposure to estimate the risk. Because if we are calculating the risk, we must know who are the most vulnerable community for that particular type of hazard. Because for every single hazard, there are different vulnerable population or vulnerable things related to that particular hazard. And what is the exposure? Because why we need these two parameters to calculate the risk? Because risk is calculated as hazard into vulnerability into exposure. So for calculating any risk, we must have the data set related to hazard, then vulnerability, and then exposure. Okay, so we must develop a e-tool for a common people or for the researchers, for like you. For example, if a first year MTech student is trying to delve into the research team or research areas, he must have these data sets very easily. Means he should, once he use this e-tool, he can able to look various risk estimate data sets. He will not able, right now what we are facing, that initially for the very first year of MTech or PhD, students are looking for the data set. If they have a data set, they are not able to convert it. For example, if they are going for the IMD data set, they will see, okay, this is .NetCDF, what is it? How we will convert NetCDF into Excel file. If they are going for the temperature data set at IMD, it is .grd format, that how to convert .grd to the Excel file. So we need to develop a e-tool that should work like this. For example, there should be a tab that is named as risk estimation, in which there is another sub tab that is high rainfall risk. If student click on that, a map should be visible to him, and that should be real-time map which is showing the high rainfall risk or extreme precipitation risk. Second sub-tab should be drought risk, and if he will click or she will click on it, drought risk maps are available to him. Then risk to ecosystem productivity maps will be there, then resilience to drought and map will be there for that. So these are the visualization, but this is, I think, less useful to a researcher rather than the second thing, because you need directly the data set. So there should be a toolbox or download also in that particular website, and if we click on that toolbox, the sub-tab will be open, that is data download, and in data download, or the second should be risk and resilience map. So once you click on the data download or risk and resilience map, you will able to get the data download, or you will able to download the risk and resilience maps across different study area, whatever the study area you have selected. So this type of e-tool is very useful or very required thing at right now, because we as a researchers are dealing with the data set and we are facing a lot of problems related to data sets. As a researcher, if we are feeling this issue, then think about the common person, farmer or district collector who is making the policy for the state or for the particular district. They are not able to get the data set. So such type of e-tool will show the data set on a real time. Then these are some adaptation and mitigation strategies. I think you know about the adaptation and mitigation strategies. No need to discuss this. Then simply I will discuss a very important thing. I think next lecture itself, Dr. Lixin Wang will discuss the IPCC. So I will not discuss much more about this. You know that this is the Intergovernmental Panel on Climate Change, which is an international body which is established in 1988, which is developed by the UNEP and the WMO. and there are some roles. So we know that IPCC do not conduct the research. It includes the research of different organizations of different researchers. So the role is initially they will understand the thing what is climate change. So I will discuss what is the main composition or structure of IPCC. So there are 3 or 4 working groups of climate change, working group 1, 2, 3 and 4. So they have different works. Accordingly, initially they will think what is the climate change, what is the issue with this. Second one will work on the impacts, what is the impact of climate change. Third will suggest what is the mitigation part, and fourth one is check whatever the mitigation we are suggesting, what is the issue with it and how we can rectify in the better way. So these are some of the IPCC scenarios. I think you know that IPCC published the assessment report. So first assessment report is in 2001 and 2007 we have assessment report which have different climatic scenarios like A1, A2, B1 and B2, but since these are very old I will not discuss them. The second one is in 2014, that is known as assessment report 5, that is AR5, and in this they have discussed 4 climatic scenarios for the future, that is RCP, I think representative concentration pathways, and you have an idea about this. So as per this representative concentration pathways, they have discussed 4 important scenarios. The first one is 2.6 and last one is 8.5. So means they think like that if we are able to tackle the climate change in the near coming future itself, then the temperature will not rise very much, it will go up to 1 degree. And if we will not do anything mitigation, or if we will not able to tackle the climate change in the better way, and we are doing the emission in the same rate or we will increase the emission, then the temperature will increase up to 3.7 degree after the end of the century, that is 2100. In between they have also classified the intermediate scenarios, that is 4.5, and in that they have shown that this temperature increase will rise up to 1.8 degree to 2.2 degree. Then in 2021 they have published another assessment report, that is assessment report 6, and in this they have shared socio-economic pathways. Means instead of RCP they have developed the SSP. They have included different things according to economy also. So that is shared socio-economic pathways. So these scenarios will be discussed in deep by the Dr. Lixin Wang. So I will not take time in these IPCC scenarios. So next thing is that whenever we think about the climate or future prediction of climate, we must have a knowledge regarding the climate models also. What is climate models? So why you think that there is a need to model the climate? What is the use of climate models? Why we need the climate models? What is the use of climate model? Right, means right now we are in 2025. So we can expect that what will be going to be happen in 2050 or 2075, so that based on that we can make the policies so that it will not affect much to us. So a model is nothing but it is a simplified version of anything. For example, if you have to think about design a car, you have to make the model of that. You will not make the prototype. Initially you will go with the model and you will check what will be going to be happen in the next coming years. So there are 2 ways to model the situation, that is physical model and numerical model. What is the basic difference between the physical and numerical model? Which one is better, physical or numerical? Physical. Okay, means everything is available then physical or numerical? Right. So numerical model is better as far as if you want to do the research work within a very short period of time. If you want to work within a month itself, then numerical model is good. But if you want to do better study, then physical model is good, because numerical model have lot of disadvantages, because it is depending upon some of the input parameters, and based on that input parameter it is creating some relationship between that. Means whatever the input you have and whatever the output you want, you will make the relationship between that two parameters or three parameters, and based on that you are predicting the future things. So for example, if you are predicting the runoff based on the rainfall, so it will give a relationship between the rainfall and runoff, and based on that you can predict the runoff for the future. But there is a disadvantage associated with this, because you are giving the rainfall and you are predicting the runoff. What about the climate, what about the different other conditions of ecosystem? For example, you have a rainfall of Bhopal and you have a data of runoff also. Based on that you have established a relationship between rainfall and runoff, and based on that you are giving the rainfall and you are predicting the runoff for the Bhopal. The same thing if I give the data set for the US also. The same, if the rainfall data is same, it will predict the same runoff for the US, same runoff for the Bhopal, and same runoff for the Delhi itself. So what is the use of LULC? What is the use of geographical condition of that particular place? Means if you have a rainfall data, you will have a runoff data accordingly. But there is no impact of geographical condition in that part. And we know that this is completely inappropriate information for the runoff. Because maybe, for example, if you talk about the hilly areas, rainfall will be there, but runoff will be different as compared to the runoff occur in the Bhopal district. So in that you have to include the geographical conditions of that particular area. So that is the advantage of physical models. So physical models are nothing but they are the replica of the same thing but in the smaller form. And numerical, I have already told. For example, if you do the rainfall runoff modeling, you can do the rainfall runoff modeling. For example, you have data set from 1980 to 2020. So initially what you do, you will take the rainfall data and you have the runoff data for initial 10 years or 20 years. So based on rainfall and runoff data, there will be equation we can form. For example, you have a rainfall like from 1981 to 2021, out of which you have up to 2010. So this is rainfall, this is rainfall precipitation, and this is runoff. So based on these two data set, there will be a relationship created between these two data set in any equation like y equal to mx plus c. Once this equation is formed, in from 2010 to 2025 itself, you will give the rainfall data set and you will predict the runoff. So this is rainfall, this is runoff. If you will give rainfall as an input with some constant m and c, it will predict the runoff. So this is simulated runoff and this is observed runoff. So since you have observed as well as simulated for 2010 to 2015, 25, what you do, you will find out the R square value, means how much how better we are predicting, because for this period you have simulated using this relation, and for the same period you have the observed data also. So based on that you will find out how better we are predicting the values. And if R square value is good, means for example R square is 0.8 or above than that, that means we are creating the relationship in the better way. So what we do, for 2026 to 2100, we will give the rainfall data set from GCMs, and based on that we will predict the runoff value. But the problem in this numerical model is that we are not considering the another important factors which are causing the runoff. The rainfall is not only the parameter which is deciding the runoff. There are other parameters like what is the LULC, what is the slope of that particular area, other geographical conditions. So in to show the better understanding of the runoff for the particular area, we must consider the geographical condition of that particular area, and for that we will take the physical model into the consideration itself. Okay, so these are some of the most widely used GCMs I think you know about the CMIP 6. So initially we are using CMIP 5, but right now we are using the CMIP 6. These are some of the latest generation of GCMs. So these are developed by different institutions of different countries, and they are different features. But whenever you are going to use the GCM dataset, I suggest never use the GCM dataset directly, because there are some biasness or uncertainties associated with the GCM dataset. So there are different bias correction techniques through which we can bias correct the means we can do the correction in the biasness available in the GCM dataset. So bias correction is a mandatory part. So what are the different techniques to correct the bias data? There are different ways to correct the biasness in the GCM. The very simple way to correct the biasness is, for example, if you have 10 or 11 GCM dataset, the simplest way is to make the ensembles of the datasets. So that is known as multimodal ensembles. Means you are taking 11 models and you are making the ensemble of that. For example, 2 more GCMs are over predicting the data, 2 are underestimating the data, so 2 are over predicting the data. So what you will do, you will take the average of that. So that will somehow give the correct value, but not the exact value. The second important bias correction technique is very simple. I think you can do. There are various techniques for bias correction, but the simplest technique for bias correction is एक बार ये देख लो कि लिक्सिन महंगा आ गए गेस्ट हाउस में. So the simplest way to do the bias correction is, for example, you have some GCM and you have data set of GCM, for example, precipitation. So in precipitation, if we talk about RCP or SSP, for example, we are opening RCP 2.5 folder. In this we have precipitation, we have temperature and other data set. In the precipitation, this precipitation is divided into 2 temporal way, 1970 to 2025, and since it is older one, so maybe it is around 2021, and 2021 or 2022 to 2100. So you will get the precipitation, that is raw precipitation data set, or before bias correction precipitation. So since you know that for this period from 1970 to 2025 we have observed data set also, which is given by the India Meteorological Department. So we have IMD data from 1970 to 2020, and we have raw PCP raw data from GCM. So we are not confirmed that whether this data set provided by GCM is correct or not, but we are very confirm about the data set which is given by the India Meteorological bias corrected after using IMD data set, and this is the bias corrected precipitation data set. Or similarly we can use this approach for the temperature or other parameters also. So this is the simplest way to do the bias correction using this. So this way is known as which method of bias correction it is? Quantile QQ mapping. So if you want to see the result of QQ mapping for bias correction, this is one of my paper. So you can see that before bias correction this is the data set, and after the bias correction it is looking like this one. So bias correction can be done like this. These are some of the GCMs, how to download the GCM. These are the links provided for that, and the data format is .nc file, that is .netcdf file. Then I think yesterday itself we are discussing about the downscaling. So we need to show that what is downscaling. So what is downscaling? Means whatever the data set we have at bigger resolution, for example, whatever the data we have available for the Bhopal, and if we want to make that data set available for the Manate, that is downscaling. Means the data set is available at Bhopal, but we need to take the or download the data for the minute itself. So that process is known as downscaling. Means the spatial resolution which is available at a course, we need to produce it at a final resolution from the GCM to RCM. That is downscaling. So there are two types of downscaling. One is dynamic and second is statistical. What is the basic difference between them? In statistical downscaling, what is the important thing to include? What is the input required for the statistical downscaling? Historical data, right? Same like this. This is the requirement of statistical downscaling. If we want to downscale the data set, we must have historical data set. This is the advantage and this is the disadvantage also. Disadvantage is like, because for the statistical downscaling we need historical data, but for a longer period, minimum for 20 years minimum, but desirable is 50 years. If we have 50 years data set, then only we can perform better downscaling itself. Okay, it's already 10. Give me a minute. Yeah, I'll ask the